Okay, so welcome to this video. We are going to look at elimination reactions. Specifically, we are going to talk about E1 reactions and their mechanisms. Okay, so we first start by defining what elimination reactions are. Okay, so what are elimination reactions? So elimination reactions have a very simple definition. Okay, so we're going to say elimination reactions or an elimination reaction. This is simply a reaction, okay, where a single reactant or a compound splits apart into two what products. So that is to say that the reactant kicks out one of its components, okay, forming two new products. Okay, so this elimination reaction is usually facilitated. It's usually facilitated by another reagent, okay, that we call as a starting material. So for example, if I have reactant A here, okay, then this reactant splits, okay, it splits. So the spelling there should be splits. So this reactant A splits, of course, with the help of a facilitating reagent. Okay, facilitating reagent, we are going to call it reagent B. So when this reactant splits, it forms two new products, okay? So there will be product C and then plus product D. Okay, so this here is essentially the elimination what? Reaction. So an example would be when I have, okay, CH3 bonded to CH2 and then bonded to Br. So this Br here, okay, in this compound, it can be kicked out, okay, and then we end up forming two new products. Okay, so we're going to say this reaction is in the presence of sodium hydroxide and let's say a reagent B. Okay, so that would be the facilitating reagent. So here, when this Br is kicked out, okay, it means here between this carbon and this carbon, there's going to be a double bond. So it's going to be C double bonded to CH2, which is bonded to H2 as well. And then plus, we're going to have the Br there, which has been kicked out. So I'm just going to write it as Br with a negative charge like that. Okay, so this is an example of an elimination what? Reaction. So now in this video, I'm specifically going to talk about the E1 reaction and its what? Its mechanism. Okay, so I'm going to erase this. Okay, so let's hope now you have an idea of what an elimination reaction is. Okay, so now let's talk about the reaction mechanisms of these elimination reactions. Okay, so there are two types. Okay, there's the E1, which we're going to talk about in this video, and then there's also the E2 reaction what? Mechanism. Okay, so each of these reaction mechanism consists of three important actions, and these are one, in each of these two reactions, this should be E2. Okay, we are going to experience what we call as the proton removal. Okay, a proton is going to be removed somewhere. And then two, there's going to be a formation, okay, of a C to C pi bond. Okay, this is what leads to the double bond that we are going to be seeing for me. And then number three, there's going to be the removal, okay, of the leaving group. Okay, removal of the leaving group. Okay, so these are the three important actions that are going to be happening in the E1 as well as the E2. So now here, let's focus on the E1 reaction mechanism. Okay, so the E1 reaction mechanism happens in two steps. Okay, it happens in two steps. The first one is the step where the leaving group would depart, okay, forming a carbocation intermediate, okay? And then the next step will be that since that reactant now has a carbocation, right? Okay, there will be a reaction between the proton of the adjacent carbon, okay, to form a pi bond. So what I mean is, for example, let me give an example here. Okay, so for example, if I have this reactant R bonded to C, bonded to R, then bonded to the leaving group X, bonded to C again, bonded to R, bonded to H, and then bonded to R there. Okay, so the first step is this leaving group here. So the X there is the leaving group. It has to leave. Okay, so it leaves with the electrons that are present in this bond here. So when this leaving group X takes the electrons that are in this bond, it means here this carbon is going to be positively charged. So what we are going to have is this. Okay, so the leaving group leaves with the shared electrons that were here. So it means now what I have is R bonded to carbon, but this carbon, since it's now electron deficient, it will be what? Positively charged like that. Then it will be attached to this R, attached to the carbon, attached to the R, attached to the R, and then this one is attached to the what? To the hydrogen like that. Okay, and then once this happens, okay, there will be a base in the solution. So I'll draw a base with two lone pairs of electrons. So this base is going to attack this hydrogen here. Okay, so it's going to come and attack this hydrogen here, meaning it will get it. So once it gets this hydrogen, okay, the electrons that were in this bond here, okay, they are going to collapse here. Okay, they're going to collapse there, forming what we call as in fact, they have to collapse here where we have the positive charge. So they will collapse there where I have the positive charge, and then they'll form a double bond between this carbon and this carbon. Okay, so what we have now is that uh, the base there, when it gets the hydrogen, it leaves with the hydrogen like that. Okay, it leaves with a hydrogen. And then what I remain with now will just be this here between this C and this C, there will be a double bond like this that has formed because these electrons that were being shared here have collapsed on this what? Carbocation. Okay, and then this carbon is attached to this R group. It's also attached to this R group. This one is attached to the R group, also attached to the what? To the R group. Okay, so here, what I've done here is actually the general thing that happens, okay, in the reaction mechanism for the what? For the E1 reactions. Right, so now let's look at two examples. So the first one is this one here. Okay, so this part here, I'm going to write it in a special way. Okay, so that it's easier for us to do the reaction mechanism. So for this reaction here, we're going to write the mechanism to show how these products are what have been formed. Okay, so let's do that. So I'm going to say here, I have this C there, which is attached to 3 methyl groups and a bromine. So I'll write it as C. Okay, by the way, I'm going to say this is a step 1. Okay, so I'll write it as C attached to bromine, okay, attached to a methyl group here, a methyl group on top, and another methyl group here. Okay, so we said the first step, okay, was that the leaving group has to leave. So the leaving group is this bromine here. So bromine has to leave like that. Okay, so when bromine leaves, it gets the electrons that have been shared in this bond here. Okay, it gets the electrons that have been shared in that bond. So meaning that what we are going to have is just going to be this. So this guy here is going to ionize. So I'm going to write here ionization. Okay, ionization. And then of course there will be water there. So I'll put water there. So when this thing ionizes, what is formed is C bonded to, in fact, this C we bonded to a methyl this side and the methyl down, okay, and the methyl on top there. And then here, since it's electron deficient there, it's going to be positively charged there, okay, because the electrons that were being shared here have actually left. And then plus this guy that left with the electrons Br minus like that. Okay, so that's what we form in step 1. And this step here is called as the slow step or the rate determining what? Step, because it's forming a stable carbocation there. Okay, and then after that, we go to step 2 now. So step 2, what is going to happen? Okay, so step 2, I'll write this guy in a very deliberate way. So it will be like this. And then on top here, this is CH3, right? But I'll write it as CH2 bonded to another H here. Okay, and then I'll write an arrow here. So now remember in this reaction, we had Na OH there. So when you dissolve that one in water, it ionizes. So it forms the ions Na plus and H minus like that, right? Okay, so this OH minus here, okay, it has a lone pair like that. So this lone pair is going to attack this hydrogen here, or it's going to grab it from what? This carbocation. I forgot to write the positive charge there. It's going to grab it from this carbocation here, so that the electrons that were being shared here collapse into that bond to form a double bond there. So what we form now will be C3H, and then bonded to C. This C now is no longer positive because it's forming a double bond on top here. So that double bond will forming to CH2 because this H here has been grabbed by this OH here. Okay, and then down I have CH3 and then plus. Okay, this one, when this H is grabbed by the OH minus, you form water, and then plus this guy here, which is Br minus. Okay, so this guy here is the same as this guy. So we've shown how these products are made by writing the what? The reaction mechanism. Okay, so this step here is called the faster step. Okay, and then this one here was the slow one, which was the rate determining step. So that's the reaction mechanism for this reaction that we wrote there. Okay, let's look at another one, this one here. So this one here, we're going to add an additional step because the leaving group that we'll see there is going to be a very poor leaving group. So we have to protonate it first, and then it leaves, and then we do the same things that we did on the first one. So I'm going to say this guy here, let me write it as a C bonded to OH, okay, bonded to CH3, bonded to CH3, again bonded to CH3. Okay, so that is what I have. And then I have plus, uh, I have plus H, which is bonded to Br, right? Okay, so what will happen here is that a leaving group has to leave from this guy here, but it can't leave here because the OH there, which is the leaving group, in this case, it's a very poor, it's a very poor leaving group. So what will happen is that this OH here, this oxygen has two lone pairs on it like that. Okay, so these lone pairs will go on and grab this hydrogen here. So the electrons that have been shared here will go to the what? To the bromine like that. Okay, so what we're going to form is just going to be what I'm writing here. So it's going to be C bonded to C3H, and then I have CH3 bonded to CH3. And then I have this bond that goes to O, and then this hydrogen has been grabbed by that lone pair on top. So I'll just write bonded to H, and then again bonded to H, which was already there, this H here. Okay, and then on this oxygen here now, there's going to be a what? Positive charge like this, because it has grabbed this what? This hydrogen there. Okay, so what it forms there, okay, what it forms there is going to be a good leaving group. Okay, it's going to be a good what? Leaving group. So the water that is going to be formed here, because this one here is the water. Okay, so once the water is formed, it's a very good leaving group is going to leave. Okay, of course, plus these bromine ions here, I write them like that. Okay. Okay, so that was step one. So we can, I forgot to write here. So that was step one. So step one was the protonation of this OH to make it a beta leaving group. Okay, so what we've done here is we've made it a beta leaving group. Okay, and then step two is going to be the loss of the water or loss of the what? Of the leaving group. So it's going to be C3H bonded to C, bonded to CH3, bonded to CH3, and then bonded to oxygen with the positive sign, and then two hydrogens like this. Okay, so in this step two, that will be the rate determining step, okay, or the formation of the ion or the carbocation. So it means this leaving group here, which is water, okay, the water leaving group is going to leave. So this guy is going to leave like that. So when it leaves, okay, I'm going to say ionization here. So when this guy, okay, this guy here, the water leaves, what I'm going to remain with now is just a pure carbocation. So it will just be C3H bonded to C, bonded to CH3, bonded to the CH3 on top. I'm going to write it as C, 2H bonded to H. And then this carbon here now it remains with this positive sign here because the water has left. So this will be positive, then plus this water that has left. Okay, so that would be the second step there, which is the rate determining step or where the ionization is what is happening. Okay, and then the third step here, it will be the first reaction where the alkene is being formed. So how is the alkene being formed? Okay, I'll write this carbocation here. Okay, so that was 2C and then bonded to C, and then arrow. So on this arrow now, remember that in my solution I had NO, NaOH, right? So I had sodium hydroxide. So that one ionizes in water to form Na plus OH minus like that. So the OH minus here with its lone pair, okay, it's going to come and grab this hydrogen there. And then the electrons that were being shared here, they are going to collapse into that bond there. So what is going to be formed will just be H3C bonded to C, double bonded to, because the electrons there have come into this bond now. So it is CH2 on top, then down CH3, okay? And then plus the water that is going to form when this guy grabs this, plus this water, it will still be water, okay? And then what was the other product that we had formed was the Br with the minus charge like this. Okay, so what I have here is this product there. Okay, and then there's the water and there's the Br what minus. So we've shown the reaction mechanism, okay, of how these products here are being formed in 3 steps. So the first one was the protonation of this OH to make it a beta leaving group. Then once we protonated it, okay, it left, it formed the carbocation there. Okay, and then in the carbocation, the OH that were in the solution, okay, they came to grab the H there, forcing the electrons that were there to collapse into this bond here. So they form a double bond there. And then when this H and the OH combine, they form water, plus that water is still water. And then plus the other product that we formed in step 1 there, which was the Br what minus. Okay, so this one here is the reaction what mechanism. So thank you so much for watching. Until next time.